In today's math lesson, we're going to graph a two-variable linear inequality. In this particular chart, we see the four inequality symbols. The two symbols here on the top both represent the greater than relationships, where the first one here on the left is strictly greater than, and the second one here on the right is greater than or equal to. These bottom two symbols represent the less than relationship, where the one here on the left is strictly less than, and the one on the right is less than or equal to. What does that mean for us with our shading? Well, things that are greater than tell us that we are going to shade above the given line. If you have a vertical line, an X inequality, that means you will shade to the right, where the positive values are. As a result, you can conclude pretty quickly that less than inequality symbols mean that you are going to shade below the line. So that's pretty nice that these are symbols that make sense. The greater thans you shade up above where the greater than things are, the positive values. The less than symbols you're going to shade below where the smaller, the negative values are. Now let's talk about the two different types of lines, because we have a greater than and a less than in comparison to a greater than or equal to and a less than or equal to. If you have strictly a greater than or strictly a less than, then your line will be represented with open dots or a dotted line. So if this was just a number line, then you would have had an open dot at the point of interest. And similarly, with the coordinate plane, you're going to show this relationship with a dotted line. As a result, I'm hoping you can quickly conclude that if you have a greater than or equal to, or a less than or equal to, that means that your lines will look like closed dots or solid lines. So the way that I had to teach myself when I was learning to do this is, if there is a line underneath it, this or equal to relationship, then that line represented in my brain a filling in of all of the holes that were possible, available, created when you just had greater thans or less thans. So the bar underneath makes the line solid by filling in the holes. As we are doing a lot of graphing in this lesson today, most of the time we will be using the slope-intercept form of the equation y equals mx plus b. And by this point in the year, I hope you are very familiar with that. Let's see how you do.